So we're going to look today at how to tell the difference on a visual model to figure out if it's an atom and an ion or two isotopes. So you're going to have some practice problems that look like this on the slide, and what you need to do is you need to figure out if these two diagrams represent A, one an atom and the other an ion, or B, two isotopes of the same element. And then once you identify that, you can figure out what the answer is. So let's start with figuring out what an atom versus an ion is. So I'm going to type. So an atom, in this example, an atom should have the same number of protons, the same number of neutrons. We could use a periodic table to help us figure that out. And really, when you're comparing these two to figure out the difference if they're an atom or an ion, the difference between these two is they would have different number of electrons, okay? So we could put for atoms, we have a certain number, the protons, neutrons, and electrons are based on the periodic table. Ions are atoms that have lost or gained electrons. Okay. So again, to figure out the two, we're really looking at electrons to figure out if it's one is an atom, one's an ion, or if they're isotopes. Now, isotopes, if you remember from last week, an isotope are two atoms, or an atom with a different number of neutrons, I should say, than the periodic table. Okay, so first thing that we need to do in a problem like this is we need to count our protons, okay? And they should be the exact same for both pictures. So in this top one, we have 2, 4, 6, 8, 10. Okay, so I'll just write 10 there. Oh my, 10 there. I'm going to double check that there's 10 on the bottom. 2, 4, 6, 8. Yep, 10. Perfect. So now I'm going to count the number of neutrons in the top one. 2, 3. We'll do 3, 6, 9, 10. So this top one has 10 neutrons. And if the bottom one has a different number than 10, we would automatically know that this answer is that B. They're two isotopes of the same element, okay? And that's because you would be comparing the two, and if they have a different number of neutrons, it would have to be an isotope. So if this has the same number of neutrons, then we'd have to look to our electrons to figure out if these two diagrams represent an atom and an ion or two isotopes. So let's count. We need 10 neutrons. 3, 6, 9, 10. So there's 10 neutrons in both of these pictures, which means right away we can eliminate an isotope, but we want to verify that one of these is an ion. Now, number 10 on the periodic table is neon, okay? Neon should have 10 neutrons, it should have 10 protons. So if one of these diagrams has more or less than 10 electrons, it would be an ion, because an ion has gained or lost electrons. So let's start with the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 electrons. So that means this top diagram is a true representation of neon according to the periodic table, because it has 10 protons, 10 neutrons, and 10 electrons. Now for the bottom, we're looking for a different number of electrons than 10, because that would then show us that it is an ion. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 11, 12. The bottom model has 12 electrons. And that tells us that the atom has gained or lost electrons. So the answer to this would be A. The answer to this visual diagram is A, because one of these atoms has 10 electrons, the other has 12. That means it has to be representative of an atom and an ion. I hope that helps.